reciprocals of linear functions. So the general form of a reciprocal of a linear function is f at x equals 1 over kx plus c. Basically, to solve for reciprocals of linear function, you will need the asymptotes, the intercepts, the domain range, and to describe the end behavior. So basically, to find the vertical asymptote of a linear function, you can have the formula of x equals c over k. Basically, this formula is a way to solve for the denominator not to equal 0. So basically, the vertical asymptote is a number that makes the denominator equal 0, because any number divided by 0 is undefined, which has properties of asymptotes. But for horizontal asymptotes, every reciprocal of a linear function has a horizontal asymptote at y equals 0, because it will never touch the 0 point line on the horizontal asymptote. So to solve for x and y intercepts, you will sub in the opposite when you were solving. So for example, if you're solving for x-intercept, you would sub in y as 0. When you're solving for y-intercept, you would sub in x as 0. So basically, rational functions are also known as reciprocals of linear functions, and rational functions have a form of f at x equals p at x over q at x, where q at x cannot equal 0, because any number divided by 0 is undefined, which brings in the properties of asymptotes. So if you were to describe the end behavior of these functions, you could say as x approaches positive infinity, y approaches 0, and as x approaches negative infinity, y approaches 0. And for example, if your k value of your reciprocal of a linear function is greater than 0, the function will look like this. But if it is less than 0, the function will look like this. So now on to reciprocals of quadratic functions. Basically, reciprocals of quadratic functions are almost the same as reciprocals of linear function, but these polynomials can have any degree in the numerator and denominator, which basically lead to having possibilities of 0, 1, or 2 x-intercepts, which will lead to having a parabolic shape and a maximum minimum point. So for example, in this function, you already have the vertical asymptotes, but since there are two solutions, every time there are two solutions, it will lead to a function having three parts, because there will be there are two asymptotes, but since there are three solutions, it will have a little parabola shape. And you can find the vertex of this by solving for an equation. So for example, for this function, you can see that you would have to factor it out to solve for the two solutions, and once the two solutions are solved for, you can solve for the vertex, and it will also have a three-part graph because it has two solutions. So for the last one, as you see, if you cannot factor out the denominator, that means there is no vertical asymptote, which means the domain can be any real number in the real number system. But that means you can also solve for the range, and the range will be greater than 0 or less than the y-intercept, depending on what values you are given. So the function would look similar to this, where the y-intercept is there and it will go down like this. Since you cannot factor out the denominator, you can solve for the y-intercept, which will help you solve for the range, which also, the horizontal asymptote is already y equals 0. So you should try the practice test and look at the key concepts given top of the practice test for reminders. Thanks for watching.